Dear viewers, welcome to our online lesson at Stigvitau 3660. In this channel, we teach mathematics and chemistry, and viewers, allow me to take you through how we organize our channel. We have these videos arranged per form in the playlist, such that in a particular form, you find mathematics and chemistry for that form, and also the videos are available on the general platform. Join me in the lessons. Kindly subscribe, share, and comment as we move on with the videos which we are presenting. In our today's lesson, we shall look at the periodic table. This is a topic learned in Form 2, Chemistry, and today we are going to look into how questions in the periodic table are tested and how, as a student, you are supposed to answer the questions. Join me and we go through the lesson. Once more, welcome, and straight away, let us look at the topic. Question number 1 gives us the table below shows part of the periodic table. The letters do not represent the actual elements. Study it and use it to answer the questions below. Now, we have letters A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, and V. And U, I beg your pardon, such that in each of these, the letters, as we have said, do not represent the actual symbol of the element. It's arbitrary. However, when you're answering this question, it is good that we maintain the letters as in the periodic table. Question number 1. On the periodic table, show the groups. On the periodic table, show the various groups and periods. So we note that the groups run vertically. So we shall have group 1, this is group 2, group 3, group 4, 5, 6, 7, and 8, at times known as group 0 or group O. Let's refer to it as group 8. For the periods, you realize that before you come to the periods, the groups are shown in capital Roman. For the periods, we show horizontally as 1, period 2, period 3, and period 4. The horizontal, the rows represent the periods. The vertical columns represent the groups. So that one is done. We have so far scored the 2 marks. Our understanding of which are the groups, which are the periods is now clear. Number 2, give the chemical family name of the following. For those elements A, C, K, and S, we refer to this group of elements as alkali metals. While DLT, that is DLT, are referred to as alkaline earth metals. That is alkaline earth metals. We refer to them as alkaline earth metals. Viewers, it is important we create or we get the difference between alkali metals and alkaline earth metals. The names are different and should not be confused for one another. Elements I and Q are referred to as the halogens. These are the salt producers, halogens, the Greek word halogens coming from, that gives us salt producers. Then we have BJ and R. These ones we refer to them as the noble gases. These are the noble gases. That way, we are able to understand the issue of chemical families. Question number 3. Give one element which occurs as a monoatomic gas. When we talk about monoatomic, we are referring to an element that exists as an individual atom. In the periodic table, the noble gases B, J, and R, that is B, all J, all R, the noble gases exist as monoatomic. These are the elements including helium, argon, and neon. Let's move on to question number 4. In question number 4, we meet that we are required to explain how do the following compounds compare, giving reasons for your answer. These are properties shown by some elements in the periodic table. For instance, atomic radius, the atomic radius of K and L. Where is K and L? K and L are elements which are in group, that is period 3, group 1 and group 2. K and L are elements in period 3. Ideally, K is sodium, that is 281, while L is magnesium at 282. So we are being asked, how do the atomic radius vary across the period? So viewers, generally we say that atomic radius decrease, the word is decrease across the period, i.e. from K to L. From K to L. Why is this so? This is due to the fact that we are gradually increasing on the number of protons, yet the electrons are being added to the same energy level. And therefore, the effective nuclear charge is increasing with the addition of the protons, or the effect of that is that this bigger or gradually bigger positive nuclear force is attracting the electrons closer to the nucleus. So we can say that across the period, there is increase in effective nuclear force. There is gradual increase in the size of the nuclear force, which is attracting the electrons closer to the nucleus, and gradually that decreases on the atomic radius. Now let's look at the trend in atomic radius between I and Q. How do they compare? We can change on the mode of answering that, and we look at which is bigger between I and Q. Unlike in the first case, you realize the atomic radius increased down the group. So in terms of comparison, we can say that Q has a bigger or larger atomic radius. It has a bigger or larger atomic radius. And we are going to give the very simple reason that Q has more occupied energy levels. Q has more occupied energy levels than I. So on the periodic table, let us note that this is fluorine, then this is chlorine, and we have bromine, and if you added that, last you have iodine. So we are saying, though we are not supposed to necessarily give the names, we're supposed to use Q and I, you find that this has more occupied energy level. The word occupied is very, very important because it shows that while this is at 2.7, this one is at 2.87. This has 2 occupied energy levels, while this has 3 occupied energy levels, and therefore the atomic radius of this one is bigger than that one. Right, let's look at the issue of ionization energy. What is ionization energy? Ionization energy is the amount of energy that an atom requires for it to lose its valence electrons when it is in gaseous state. So we are talking about K and S. K and S are elements which are in the periodic table, whereby we have the elements at, this is arrangement 1, this is arrangement 2, 1, this arrangement, electronic arrangement 2, 8, 1, and this is at 2, 8, 8, 1. So we are comparing which of these two has a maybe bigger or higher. Let's choose the word higher because ionization energy is a value. Higher ionization energy or lower ionization energy. Which one requires more energy for it to lose an electron? You find that S has a larger atomic radius, so it easily loses its one valence electron. Therefore, it requires less energy for this valence electron to be lost when we compare it with K. In summary, we are saying S has lower fast ionization energy than K. S has a lower ionization energy than K because it requires less energy to lose its valence electron compared to K due to its larger atomic radius. That means the valence electron is very, very far from the positive nucleus. It is weakly attracted. So the moment it is lost, less energy is required here for it to be lost, and more energy is required here. So let's put that one in summary, and we're going to put it that S has lower ionization energy, and we are referring to the first. When we are losing the first electron, than K, that is the first bit of it, and we can say this is because S has a larger atomic radius. It has a larger atomic radius. Hence, S loses its valence electron, easily. By easily, we mean with less energy. So we need to, I see we've skipped on a question in C. We can look at it. How do the reactivity of I and Q compare? Which one is more reactive than the other? So viewers, we are talking about fluorine and chlorine in the real terms. 2,7 and 2,8,7. The halogens react by gaining electrons. So you find that I, which is fluorine, has a smaller radius. So it can easily attract an electron to itself compared to Q. So in short, we are saying I is more reactive than Q, since I has its outermost electron closer to the positive nucleus, so it attracts electrons with a greater force than in Q. We can put that one in summary and say I is more reactive than Q, based on the reason that I has a smaller atomic radius than Q, and hence I attracts electrons more strongly than Q. I has a greater ability to attract electrons to its valence electron, to its outermost energy level than in Q. So far, so good. Let's look at part E. This is an area which requires us to state the bond type and the type of structure formed by some of the elements and their respective compounds drawn from that periodic table. So we are asking here, if you look at the element K, how or what kind of a bond do its atoms form? So viewers, I would like us to be very specific here. We are talking about the atoms of element K. K, from the periodic table, if we can look at it, is the element 281. Basically, this is an element which is in the group 1, it is amongst the alkali metals, and also in period 3. But more importantly, we see that it has one valency electron. So it is amongst the metals. In short, we are asking alkali metals, how or what kind of a bond do their atoms form? So that is rather straightforward. The atoms of alkali metals form metallic bond, a metallic kind of a bond, and consequently, many of them form the giant metallic structure. The giant metallic structure. The structure is giant metallic. Let's look at the chloride of L. The chloride of L. L is an element amongst the group 2, the alkaline earth metals, with electronic arrangement 2, 8, 2. It has 2 electrons on the outermost energy level. That means when it is forming its chloride, we expect that L valence 2 with the chlorine valence 1 will form the compound L chloride. And that kind of a bond between a metal and a non-metal will be an ionic bond. An ionic bond. And it will stretch after being repeated several times or thousands of times to form a giant ionic kind of a structure, giant ionic structure. Let's look at the chloride of M. The chloride of M. M in the periodic table is an element in group 3, period 3. So it has the arrangement 2, 8, 3. Viewers, we have to be very careful here. We try to position M in the periodic table, and you'll find that M is aluminium as an element, Al, atomic number 13. Aluminium, when it combines with the chlorine, aluminium, when it combines with the chlorine, forms aluminium chloride. So here, we shall work from the knowledge of M is aluminium chloride. So aluminium at valence 3 combines with the chlorine at valence 1 to form the compound aluminium chloride. Aluminium chloride. What special chemistry do we know about aluminium chloride? We know that unlike sodium chloride, magnesium chloride, unlike those two, which are ionic, aluminium chloride forms covalent bonds between aluminium and chlorine. So viewers, it is very important we get that chemistry, that aluminium chloride is not ionic. Indeed, it is covalent. And so, the bonding in aluminium chloride is covalent, and the structure is simple molecular, or what modern chemistry calls molecular, just molecular. So, we are going to say the chloride of M is covalent in its bonding, and it forms a simple molecular, also referred to as just molecular. Molecular, the type of structure. Here, viewers, the word simple has over many years been used to show the weakness and not so extensive a bond compared to giant. Giant creates the picture of an extensive kind of bond which extends millions and millions of bonds, and also a huge resultant compound or structure. Let's look at the oxide of N. The oxide of N at 284. 284. This is silicon, Si. Silicon does not behave like a metal in the sense that it prefers to share its electrons. Metals generally transfer their valence electrons, but in silicon there is sharing of the valence electrons with oxygen, so that we form a covalent bond, and we normally say that the structure is giant covalent. And in the old days, we refer to it as giant atomic, the giant atomic structure. We look at the chloride of S. The chloride of S. The chloride of S, S being an alkali metal with the valence 1, therefore, we are going to see that that one is ideally potassium. S has valence 1, chlorine valence 1, and then we form S chloride. And being drawn from alkali metals, then it transferred its electron to chlorine, and that means it is ionic, and therefore the structure is giant ionic. We have another question here that talks about the type of bond between molecules of U, the molecules of U. So viewers, we be very specific here and note that we are not talking about between atoms of U. It is between the molecules of U. Ideally, this being fluorine, chlorine, and this is bromine, between the bromine molecules, that is one molecule to another, between the molecules, if these are two bromine molecules, what kind of a bond is found here? We refer to that bond as the van der Waals forces. It is a kind of a special bond that exists between molecules which are close together. So we have van der Waals forces, a kind of a special bond between molecules which are usually close together, and that is the issue. However, van der Waals forces are not able to create a huge structure, but they in the category of simple molecular structures or simply molecular structure. So viewers, we've managed to work out question number 1, 2, 3, and 4. And coming up next, we look at question number 5, 6, and 7. Let us look at question number 5. In number 5, we are saying, state and explain the nature of the solution of the chloride of M in terms of its pH. So here, there are some key items that we need to look at. One, we need to talk about the nature of the solution in terms of what? That is the chloride of M in terms of its pH. We need to identify what is M as in the periodic table. M is that element 283, that is group 3, period 3, and we had identified it to be aluminium. Viewers, we said that the chemistry of aluminium chloride is a special one, in the sense that when M, as in the periodic table, or aluminium is put in water, aluminium chloride is hydrolyzed by water to form the aluminium hydroxide, which is insoluble, and hydrogen chloride, or HCl. It is the HCl which makes the solution highly acidic. So that forms our answer, and we're going to give it that M chloride is hydrolyzed by water. It's hydrolyzed by water to form a precipitate M hydroxide and HCl, i.e. M chloride, plus water liquid forms MOH3 plus 3HCl aqueous. We balance this equation whereby we have the valency of aluminium, or M, being 3, and that of the chlorine being 1. So the formula is MCl3. 3 chloride ions. We have 3 hydrogen ions plus these 3, that makes 6. So if we balance with a 3 here, that will make us have 6 hydrogens, 6 here and 6 here, 3 oxygens and 3 oxygens, 1 M, and I believe the other bit is balanced, 3 chlorine, 3 chlorine. One important thing, viewers, we need to understand is that in water we have OH and H. The OH are taken by M, and they are so captured that they form the precipitate together with M. Indeed, they are removed from the solution. The OH ions are removed from the solution, leaving hydrogen ions which combine with the chlorine. In short, we are having 3 hydrogen ions free and 3 chloride ions which are free in the solution. We know that the hydrogen ions are responsible for the acidity. Together with the hydroxonium ion, the hydrogen ions contribute to the acidity of the solution. And that is why we are saying that M is hydrolyzed by water to form a precipitate of this and that. To answer the question, we are going to summarize and say that the solution is acidic. This solution is acidic. The solution is acidic with a pH of, we can pick on 1. HCl is a strong acid. The pH value may lie between 1, 2, or 3. But since pH is a value, we are going to take one value drawn from the strong acid, and that way we are picked on pH 1 to signify a strong acid. So that is a very strange behavior, I can call it so, of aluminium chloride. As we had said, unlike the chlorides of sodium and magnesium, which are ionic, they dissolve in water to form neutral solutions, that is sodium chloride and magnesium chloride, aluminium chloride is not ionic. It is covalent. And when in water, it is hydrolyzed by water, and the moment aluminium hydroxide, which is a precipitate, is formed, we have the solution turning acidic due to the formation of HCl. So that is some Form 2 chemistry which we can carry on with other forms. Let's look at question number 6. Write down the equation for the reaction between iron powder and element Q. We need to focus back and try to trace what is Q in the periodic table. Q at electronic arrangement 287 or atomic number 17 happens to be chlorine. So in short, we are asking what is the nature or how is the reaction between chlorine and iron filings or iron powder, finely divided iron here. So we find that iron in the background reacts with the Q, which is chlorine. Viewers, we shall note that Q exists as diatomic gas. So whenever we are writing Q, we are writing it in place of chlorine. So iron reacts with the chlorine to form iron 3 chloride, which we shall show as that. This is because the iron is oxidized by chlorine to iron 3. The valency of iron at this point is iron 3. So the 3 becomes here. Chlorine has valency 1, and that is the formula of the compound, and it is in solid form. We are saying that this reaction is going to be written in place of the reaction iron solid plus chlorine gas forming iron 3 chloride solid. So the 3 chloride ions, the 3 chloride atoms, we balance with a 3 here. So we bring in a 3 here, and this makes 2, so that we have a 2 here, 2 iron, 6 chlorines, and that means we balance with that. That way, we are using this to enable us understand the chemistry that is required. You realize iron, when it reacts with chlorine gas, forms not iron 2 chloride, but it forms iron 3 chloride as shown here. This is because chlorine is a strong oxidizing agent. It oxidizes the iron 2 formed further on to iron 3 chloride. And that is why we have in that. So viewers, this is enabling us to draw this one, and we put in all aspects of the chemistry, showing the Q exists as diatomic, and the state symbol for Q is a gas producing a solid. Question number 7. Write down the formula of the compound formed from the following elements and radicals. So we have the element K, L, and M. We are going to refer back to the periodic table and see what are their valencies. You find that K is an element in group 1, so valency 1. L is in group 2, so valency 2. While M is an element in group 3, hence valency 3. With the knowledge of these valencies, it becomes quite easy for us to now write the chloride of K. What is the formula for the chloride of K? That's what the question is asking. Write down the formula of the compound formed from the following element. These are the elements, and the following radicals, the likes of nitrates, the carbonates, the sulfates, and I have also added the chloride and the oxide. So first and foremost, we can illustrate the chlorine as having a valency 1, the nitrate NO3 valency 1, the charge is not important, the valency is 1. The carbonate CO3, the valency is a 2. The sulfate SO4, the valency is a 2. The oxide the oxygen has a valency of 2. As we write the chemical formula, we shall for now concentrate on the valencies and how we cross them out. For instance, K with valency 1 reacts with chlorine at valency 1, and we form KCl, and that is done, valency 1, 1. We move on to K nitrate. We have valency 1, 1, and that formula is balanced. So we are able to have that. Viewers, I would like us to master on the printing. Show the elements in their capital form unless we have the same element represented by 2 letters. The first letter is capital, the second letter would be small. But if a radical is shown by 2 different elements, both of them must be capital. So we look at K carbonate with valency 1 and a carbonate at valency 2. The 2 comes here and we have K2CO3. The same case with the sulfate of K. The valency here of sulfate brought down to 2, and that comes that. The oxide of K, like that, the valency of oxygen is 2, brought down here, and the valency of potassium brought here, that makes the oxide of K, K2O2. Let's look at L. The chloride of L at valency 2 with chlorine, valency 1. So this one is brought here, the L is brought here, and that forms L chloride. L nitrate goes by that formula in the sense that the nitrate is 1, the L has a valency of 2, and so we bring a 2 there. L has a valency of 2, so the carbonate also has a valency of 2. If you were to do these 2 here and these 2 here, they cancel out, and that way we leave it as L carbonate. Sulfates, the same, valency 2 and the sulfate at valency 2, and that cancels out like that. The oxide of L, we have L valence 2 and oxygen valence 2, and that cancels out at that point. We have M at valence 3, chlorine at valence 1, meaning that 3 is brought down here, chlorine 1. Then we have M nitrate, the same case. We have valence 3, so at nitrate we have a 3 here, and valence of a nitrate is 1, we remain 1. So NO3 into brackets 3. We have L carbonates at valence 3 and carbonate at valence 2, then L2, create space here, L2, then the carbonate here at 3. Oh, sorry. We redo that one. It's not L, but it is M. Let's do that again. It is M at 3, the carbonate at 2, and the M at 3. So that is correct. We have M at 3, carbonate at 2. Then we move on to M sulfate. M sulfate. M at 3 and the sulfate at 2. So M2, SO4, 3 of them. And then M oxide with M at 3, the oxide at 2 means 2 and a 3 there. And that basically is aluminium oxide. The last question. Select the elements that can form an ion with a charge of -2. Select the elements in the periodic table that can form an ion. So we are talking about ionization. How well or how does a particular atom ionize with a charge of -2? So in this case, we look at ion formation. Atoms form ions with a charge of -2 when they gain electrons. Electrons are negatively charged, so we check in the periodic table which elements require to gain 2 electrons. This must be elements in group 6. These are elements in group 6. So we have either H or element P. Remember, if we pick on H, H is the element with arrangement 2, 6. It gains 2 electrons to become 2, 8, and therefore have a stable octet configuration. P is at 2, 8, 6. It requires to gain 2 electrons to become stable, and therefore once it stabilizes, then it will have a charge of -2. What about the element that forms an ion, a stable ion with +2? These are elements that require to lose 2 electrons and to become stable. And which ones are these? These are elements which are in group 2, the alkaline earth metals, and they include D, L, or T. We have D, L, or T. Viewers, we come to the end of our analysis of the periodic table, and I would like us to note here that in discussing the periodic table, you cut across very many aspects of chemistry, be it valences, be it chemical families, be it bonds, be it structures, be it the reactions, because it affects the kind of chemical formula that will be formed. And you're also seeing the aspect of trends across the period, trends down the period, and these trends could be in properties like atomic radius, melting point, ionization, So as we revise on this, I believe we are now in a very stable position to understand the periodic table. One of the items that I wanted you viewers to capture is that the need to show the electronic arrangement is very crucial. So as we summarize, I would like us now to show the electronic arrangement. The first element, hydrogen, has valence as electronic arrangement 1. Helium has 2. We have lithium at 2, 1. This is 2, 2. This is 2, 3, 2, 4, 2.5, 2, 6, 2, 7, 2, 8. Then 281, 282, 283, 284, 285, 286, 287, and 288. This is 2881. We have 288 and 2. Since in Form 2 level, we normally focus on the first 20 elements, their physical and chemical properties. Viewers, that has been a very interactive session whereby we have digested on properties of elements in the periodic table and how to go about answering these questions. I'm very grateful for you joining me in this channel, and I will be very glad if you could put in your comments about this lesson in the comments section. In our upcoming lesson, we shall focus on more details about structure and bonding, whereby we shall be able to see how atoms bond in ionic bonding, covalent bonding, and so on. I have been your teacher, Steve Gitau, in the channel at Steve Gitau 3660. Thank you for joining me, and I look forward to meeting you in upcoming videos. Thank you.